Okay, moving on to part D, we are asked to determine whether the series converges or diverges and to state the conditions of the test used for determining convergence or divergence. So this question is set up really well to use the integral test because this question is all about the improper integral, which we did in part C, so we can utilize that in part D. So in order to apply the integral test, we need to show the conditions. 3 conditions. Is the function positive? It's going to be positive because after x equals 2.5, the denominator is positive and the numerator is always a constant, which is positive. So the whole thing is going to be positive over this interval 5 to infinity. It's continuous because the discontinuities happened before 5. It's decreasing because the numerator is a constant and the denominator continues to increase, so the whole thing decreases. So now that we stated our conditions and that they are met, we can apply the test that the integral from 5 to infinity of f of x dx converges, utilizing what we found in part C. Therefore, the series converges by the integral test. Now that's one way to approach the problem, which works really well in this scenario. But another way to approach the problem is using limit comparison test. The way that works is you have your a sub n is f of n, and then what you're going to compare it to is b sub n, which is 1 over n squared in this scenario. You have 1 over n squared. And you say that both of these are greater than 0 for all of n is greater than or equal to 5. And then the limit as n goes to infinity of a sub n over b sub n is equal to 3/2, which is positive and finite, meeting the rules. Therefore, since b sub n, 1 over n squared, is a convergent p-series, that means that a sub n also converges by the limit comparison test.